These are Algebra 1 notes for 4.5, Solving Systems by Substitution, Day 2. So we learned how to solve systems of equations yesterday by substituting. So these first three questions are a review from yesterday. So let's take a look. On this first system of equations, we have y equals x plus 4 and 4x plus y equals 24. And so remember, we're always looking to isolate one of the variables. So on this one, y has already been solved, and so it's x plus 4. So we're going to plug that in for this y right here. So we're going to say 4x, and we're going to substitute x plus 4 for y equals 24. So now let's combine like terms. We have 5x on this side. Subtract 4 from both sides. And you get 5x equals 20. Divide by 5. And x equals 4. And now that I know x equals 4, let's go back to our original equation right here. And we'll plug in the 4 for this x and solve for y. So we have y equals 4 plus 4. So y equals 8. So our solution to this system is 4, 8. Okay, let's look at the second one. Again, y has already been solved. And it says y equals 2x plus 8. So we're going to substitute that 2x plus 8 for this y in the equation. So 2 times 2x plus 8 minus 4x equals 16. Distribute. We have 4x plus 16 minus 4x equals 16. So let's combine like terms over here. We have a plus 4x and we have a minus 4x. Those cancel out. So we're left with 16 equals 16. And so when our variable completely disappears like this, and we're left with two numbers, we need to ask ourselves, is this a true statement? And it is. 16 does equal 16. So we're going to say infinite solutions. There are infinite solutions to this system. Okay, let's do number 3. On number 3, we have y minus 5 equals x. So this x has been isolated, and we see that it equals y minus 5. So let's take that y minus 5 and we're going to plug it in for this x right here. Okay, so we have 2y equals, and let's distribute, 2y minus 10 minus 14. So I have 2y equals 2y minus 24. So let's subtract 2y from both sides. And when I do that, looky here. We end up with 0 on this side equals negative 24. So our y's disappeared and we're left with these numbers. And is this a true statement? Is 0 equal to negative 24? No. So when that's the case, we're going to say there's no solutions. So that's a review from yesterday. We had solutions where we had one solution, infinite solutions, and no solutions. And today we're going to continue to use substitution, but in the problems that we have today, unlike yesterday's, on all of the ones we did yesterday and including these reviews, all of the equations had already been solved for y or for x. So the variable was already isolated. As we go forward, we're going to have to do a little bit of solving before we can substitute. So I'll show you what I mean. We'll look at number 4. So it says here, sometimes when using substitution, you will have to solve one equation before substituting. So here's our two systems, 3x plus y equals -1, and x minus y equals 5. And so the hint here says, solve the second equation for x, then substitute. So let's look at the second equation. It says x minus y equals 5. If I want to get x by itself and solve for x, I would need to add y to both sides. So I end up with x equals 5 plus y. So now I know what x equals. X equals 5 plus y. So let's take this 5 plus y and we're going to substitute it for x in the other equation. So we have 3x plus y equals -1. That's the original equation. And since x equals 5 plus y, we're going to plug that in for x. 3 times 5 plus y equals -1. So let's distribute to begin with. 15 plus 3y plus y equals -1. Now let's combine like terms here on this left side. We have 15 plus 4y equals -1. So we're trying to solve for y, so we want to get it by itself, so I'm going to subtract 15 from both sides. And I'm going to move up here. So now we have 4y equals -16. Divide by 4, and y equals -4. Now, once I know that y equals -4, I can plug that in to one of our original equations and solve for x. So, I think the easiest thing to do would be to take this equation, the one that we solved at the very beginning, x equals 5 plus y. And since I know that y equals -4, we're going to say x equals 5 plus -4, so x equals 1. So our solution, our final solution to this equation, or system of equations, is 1, -4. Okay, on 5 and 6, it says for you to try it. So why don't you hit pause in just a moment and try these yourself. And what I suggest is you look over the two equations and to see which one could easily be solved for either y equals or x equals. Just look and see which one you could do and then solve it, and then go ahead and do your substitution. So give it a try, hit pause, try it, and then you can come back and see how you did. Okay, so there's a lot of work shown on this page, and let me walk you through. So hopefully on your first equation, when you solved it, you got 2, 11. That's the solution. And then it asks what is the value of x plus y, and 2 plus 11 is 13. Now let's talk through how we did it. I put an arrow right here showing that this is the equation that I used to solve for y. I added 3x to both sides, so we got y equals 3x plus 5. And once I know that y equals 3x plus 5, I substituted that for the y in this equation right here. So instead of 3 times y, we did 3 times 3x plus 5 plus the 2x equals 37. Use distributive property, 9x plus 15 plus 2x equals 37. Then you have like terms right here, 9x and 2x. So that's 11x plus 15 equals 37. Subtract 15 on both sides, and you get, and I did that up here. I came up here. 11x equals 22. Divide each side by 11, and x equals 2. Now, once you know that x equals 2, you can plug that in and figure out what y is. So I plugged it in. Here's my little check mark right here. I plugged it into y equals 3x plus 5. So here's y equals 3x plus 5. We put in a 2 for x. So you get 3 times 2 is 6 plus 5 is 11. So y equals 11. Then part B of this question said, what is the value of x plus y? So we put an x in of 2 plus 11, and x plus y equals 13. Okay, now on number 6, I hope that you were able to get 5, 10 as your answer. So again, you can look my work over. To start with, I looked at the two equations and I felt like the first equation was the easiest to solve. So I subtracted 2x from both sides and ended up with what's circled in red here, y equals 20 minus 2x. So once I knew what y equals, I substituted that for y in this equation. And you can see the work there, 6x plus 2 times 20 minus 2x equals 50. So 6x plus, and then you had to distribute. 2 times 20 is 40. 2 times negative 2x is minus 4x. And we just keep solving out, solving for x, and we get down here to x equals 5. And once you know that x equals 5, I use this equation again, y equals 20 minus 2x, and I put the 5 in for x, so you get y equals 20 minus 10, and so y equals 10, right down here. So then part B of this question said, what is the value of x times y? And 5 times 10 equals 50. So there you go. Let's go on. Okay, on number 7, it says define the variables and set up the systems and then solve. So it says admission to the PHS basketball game was $3 for adults and $2 for students. If 300 tickets were sold for a total of $825, how many tickets of each were sold? So the first thing we need to do is define the variables, and that means we're going to write let statements. So we're going to let, and I'm going to let x equal the number of adult tickets. When you're defining variables, you need to look at what it's asking for in the question. How many tickets of each were sold? That's going to help you know what we're defining. So we're trying to find out the number of tickets for each. So x is going to be the number of adult tickets, and we're going to say y is the number of student tickets. Now we need to set up two equations, and the equations, one of them is going to deal with the number of tickets that were sold, and the other one's going to deal with the amount of money that was raised. So to get the number of tickets that were sold, if x is the total number of adult tickets and y is the number of student tickets, then x plus y will equal 300, because that's how many people, or that's how many tickets were sold. Okay, then for the money, it's $3 for the adults and $2 for the students. So 3 times x plus 2 times y is going to equal 825. So now that we know what the equations are, we need to look and see how can we solve one of them so that it will either say x equals or y equals, doesn't matter which one, and then we can substitute. So I'm just going to go ahead and use this first equation. I'm going to solve it for y. I'm going to subtract x on both sides. So I get y equals 300 minus x. So now that I know that y equals 300 minus x, I'm going to substitute that for y in the other equation. So we have 3x plus 2, and we're going to substitute in 300 minus x for y equals 825. So we have 3x plus 2 times 300 is 600 minus 2x equals 825. So subtract 600 and we have 3x minus 2x equals 225, and 3x minus 2x is x. So there's 225 adult tickets. Now, we need to find the number of student tickets. So let's go back up here to our original equation. And in fact, I'll just use this equation right here, y equals 300 minus x. So y equals 300 minus 225. I'm just substituting this in, and so we get y equals 75. So there were 225 adult tickets. Didn't spell that very well. 225 adult tickets and 75 student tickets. Okay, let's try number 8. Okay, on number 8 it says a jar contains nickels and dimes. There are 20 coins in the jar, and the total value of the coins is $1.40. How many nickels and dimes are in the jar? So let's go ahead and solve this. We're going to first we need to make our let statements. So remember, when we're making our let statements, let's look at the question and see what is it asking us to find. It's asking us to find how many nickels and dimes are in the jar. So that's going to help us know that x needs to be the number of nickels and y equals the number of dimes. Now, really, you can use whatever letters you want, and you could even make x be the dimes and y be the nickels. As long as you set everything up correctly, it'll still come out right, no matter which letters you use. So I'm just using x for nickels and y for dimes. So let's go ahead and set up two equations. One of the equations is going to deal with the number of coins that are in the jar. So x, the number of nickels, plus y, the number of dimes, has to total 20, because there's 20 coins in the jar. And then the value of our coins is going to be $1.40. So what's the value of a nickel would be 0.05 x plus 0.10 y equals $1.40. So now we want to solve this and be able to use substitution. So we want to solve for either x or for y. So this time I think I'll just solve for x. You can do whatever you want. There's more than one way to solve this. But I'm going to go ahead and subtract y from both sides. And so I get x equals 20 minus y. So now I'm going to come over here to the other equation. And so instead of 0.5x, I'm going to write 0.05 times 20 minus y plus 10 cents y equals $1.40. So now we need to distribute. And when you multiply 5 cents times 20, you're going to get $1 minus 5 cents y plus 10 cents y. Let's combine like terms right here. So we have $1, and you have 10 cents y minus 5 cents y is going to be plus 0.05 y equals $1.40. So now we're going to subtract $1, and you get 0.05 y equals 40 cents. Divide by the 5 cents, and we find out that there are 8 dimes. So if there's 8 dimes, let's go back up to our original equation. And so x is equal to 20 minus 8. I'm substituting the 8 for that y right there. So x equals 12 nickels. So we have 12 nickels and 8 dimes. Okay, let's look at number 9. Okay, on number 9, it's given you two equations. Equation 1 is 2x plus 6y equals 12, and the second one is x minus 2y equals 9. It says if you want to substitute for x in equation 1, which of the following expressions would you use? So it's saying if we want to substitute this x, that means that this equation needs to be solved for x, because I can't substitute for the x in equation 1 until I have equation 2 saying x equals. It has to be solved for x. So let's just do that right now. Let's solve that equation for x. So I'm going to add 2y to both sides. So x equals 9 plus 2y. So this is what I would substitute in for x in the other equation. So let's look at our answer choices, and here we are with letter B. Now try the same thing on number 10. You have two equations, and it says which expression could be substituted for y in equation 1. So we want to substitute for this y, which means in this equation it needs to say y equals. So hit pause, try that yourself, and see how you do. Okay, so I hope you answered D, because if we want to substitute for y, this equation needs to say y equals. So I subtracted x from both sides, and I got y equals 6 minus x, and that was letter D. Okay, so there's your lesson on substitution day 2. Hope you're getting the hang of it, and see you in class.